Welcome to Module 12.1, where we are going to be learning about structured query language. Structured query language, or SQL, or SQL, however you'd like to say it, is a programming language that allows us to operationalize our relational algebra operations into a database and interact with our data in a database management system. In this video, we will be converting some of our relational algebra expressions we did last time into SQL code, focusing on our unary operators of select and project. In part 1 of this video series, we're going to be learning the basic select from where block and also looking at comparison and logical operators. In the second video in this series, we're going to extend the basic select from where using group by, having, and order by clauses, and also introduce aggregate functions. In part 3, we're going to introduce two new operators, in and is, and talk a little bit more about pattern matching. In part 4 of this video, we're going to work through an example that is very similar to what we will be doing in assignment 3, so I think that's going to be of particular value to you guys. To get started, we'll look at the general form of the select from where block, which is that we start with the word select, and all of our SQL queries that are reading data are going to start with select. Select, and then some comma-separated list of columns, the keyword from, and then a comma-separated list of tables, and then the keyword where, and some Boolean condition that we are evaluating to be true or false for each tuple. And that where statement is optional. We can just do select attributes from table without any where. So column list is this comma-separated list of columns or attributes that we want to project. Table list is a comma-separated list of tables or relations that we're using in the query. And then condition is a Boolean expression that identifies the rows that are to be retrieved by the query. So looking at one of our most basic relational algebra expressions here, we want to select tuples from the relation course. And in this case, we're not providing any Boolean expression that we're evaluating the tuples. We just want to return all attributes and all tuples. So the SQL statement that corresponds to this relational algebra is select asterisk, and asterisk just means all columns or all attributes, from course. And as a reminder, SQL, structured query language, is not case sensitive as far as your SQL operations go, but typically we write our keywords in all caps, especially in these examples, to just kind of illustrate that these are special keywords. So select asterisk from course is going to take our course relation and then create a new relation that looks exactly the same because we're selecting all attributes and all tuples from the course relation. We also said in our select relational algebra operation, we can provide an expression that we want to evaluate all the tuples against. So in this case, we're selecting from the course relation, and we only want tuples to where this expression evaluates to true, where the values of the hours attribute equals 3. So as we look at each one of these tuples, for the first one, that is true. For the second, it's false, false, true, true, true. And we wind up with this resulting relation. And the SQL that we would write to operationalize this relational algebra is select asterisk from course where hours equals 3. Now, if we want to specify certain attributes, instead of the asterisk, we can provide the list of attributes. And this is going to project just the attributes that we are interested in. So in this case, we're projecting all of the attributes. This is exactly the same as if we had just used the asterisk, but we could specify a subset of attributes, or we could also specify that the attributes should be projected in some other order. Now, back in module 6.1, when we introduced relations, we said that tuples and attributes are all stored in no particular order. So that means that we can specify the order that we want the attributes returned in with no penalty. We can also have multiple criteria in our where statement. So this relational algebra statement from the last set of videos where we select from the course relation where hours equals 3 and credit equals G would be select asterisk from course where hours equals 3 and credit equals G. So the DBMS is going to evaluate each tuple against these two Boolean expressions and return a new relation that has only tuples meeting that criteria. Okay. Similarly, we could say select asterisk from course where college equals business or college equals engineering, and this is going to create a relation that has the tuples where the value for college is either business or engineering. And going back to the kind of tricky example we had in the videos for modules 11.1 and 11.2, depending on how you put your parentheses around these expressions in your where statement, what look like two very similar statements can give us very different results. So in this case, select asterisk from course where college equals business or college equals engineering and hours is greater than 2 is going to give us everything where it's business or engineering and the hours is greater than 2. Whereas this one, select asterisk from course where college equals business or college equals engineering and hours equals 2, is going to return business courses even if the hours is not greater than 2. Right? So take a moment to look at the difference in these two queries and really kind of consider why this tuple is returned by this query but is not returned by this other query. And keep in mind, if we don't use parentheses in these expressions, by default AND is going to be processed first. Okay, so the parentheses add a little bit of clarity to that, and also I would be suspicious that across multiple DBMSs we might get different results if we don't use the parentheses appropriately. So better to use parentheses than not to. Okay, so in this case, we are not selecting, but we are projecting from our course relation. So we're going to project from course these three attributes that we're interested in, name, course number, and college. So we say select, name, course number, college from course. So this is the comma separated list of attributes that we want to project, and we would get in result a new relation that has a reduced degree or a reduced number of attributes. As we've previously described, we can nest our operations. So in this case, we have a select operation nested within a project operation. So we're going to select from the course relation all tuples that have a value for college of either business or engineering. And then from the relation that is generated by this expression, we are going to project these three attributes that we are interested in, name, course number, and college. So we write the SQL for that as select, name, course number, college, from course, where college equals business or college equals engineering. And so now we get a new relation with a reduced degree, only the three attributes that we projected, as well as a reduced cardinality with only the tuples that match this Boolean expression. All right, so one thing that I would like to point out at this point is when you run SQL queries, and we've talked a lot about these relational algebra expressions evaluating to a new relation, there is a slightly different operationalization of relational algebra as opposed to what your DBMS does with SQL queries. So what we previously saw in the videos from 11.1 and 11.2 is that if we project an attribute that is not a superkey or that is not unique, we would get only the unique tuples. However, if you were to run the SQL query that corresponds to this relational algebra, select college from course, you'll find that you do get a relation as a result that has duplicate rows in it. Okay? So this is just a little bit of nuance where what your DBMS is returning is a view of a relation, not an independent relation in and of itself there. But if we wanted to faithfully represent what the relational algebra operationalization of this query would be, we can use the distinct keyword and say select distinct college from course, and then we get the exact same thing we expect from the relational algebra. Alright, so that's it for our first video from module 12.1. In the next video, we're going to extend the select from where block with some additional operators.